Good evening, everyone. Welcome back to 360DigiTMG's data, the domain analytics program. It is the third day of domain analytics. The first day we have discussed about what are the machine learning application we'll be having when it comes to web and mobile analytics, where exactly we can apply the machine learning algorithm and we can improve the process when it comes to web and mobile analytics that we have discussed. And the next day that we have discussed about the CRISP-ML methodologies. CRISP-ML, cross-industry standard process machine learning algorithm. What are the phases we'll be having? Like we have 6 phases when it comes to CRISP-ML methodologies. What we will be having in that each phase that we have discussed in the previous class. In today's class, we will be discussing about EDA, exploratory data analysis. EDA, exploratory data analysis. Whenever you are receiving the data from client or whether you are web scraping, once you have received the data, you have to do the diagnosis. You have to go through the data and you have to find out the inferences from the data. Before that, whenever you are collecting the data from different sources, there could be anomalies in the data. In that case, we can do the pre-processing. Anomalies in the sense like whenever you are conducting surveys, some people might not be comfortable sharing their age. If you are conducting a survey to collect the ages of different people, in that case, they might not be comfortable sharing the age. And some people, they might not be comfortable sharing with the weight. Like that, some people might not be comfortable sharing with address. So these all data comes under missing data. So whenever you are doing the survey, these kind of mistakes might happen. And the values that you are entering into the data sheet are manual. Whenever you are conducting the survey, the values that you are entering into the data frame, it is manual. In that case, human error also possible. Like instead of 10, I might be entering something like 0 or 1 or 100, something like that. So it is a possibility. There could be a possible human error. In that case, how can we find out that? All these things, whatever the anomalies, these are called anomalies in your data, that we will be removing using the pre-processing. So we have 2 kinds of data, like you already know, whenever you are working on the machine learning model, you have unstructured data and you have a structured data. When you have a structured data, you will be having different pre-processing techniques. Structured data means the data that is available in tabular format. The data that is present in the tabular format. You can say, for example, data that is available in SQL Server or Excel sheets or .csv sheets. All the values, all the data that is available in SQL Server. The SQL Server itself, data is stored in columns and rows, right? Tabular format. So whatever the data that is available in tabular format, in that case, we will be calling it as structured data. When it comes to unstructured data, we will be having videos. The data that you can't represent in tabular manner, that we will be calling it as unstructured data. For example, you can take videos, audios, or you can take text as well. These are all comes under unstructured format. So we'll be having different pre-processing techniques when it comes to structured as well as unstructured. Agenda of this session, we'll be going through the exploratory data analysis. Whenever you're having the data, right after doing the pre-processing, we will be going for EDA, exploratory data analysis, and how we will be doing the data pre-processing. It could be in web and mobile analytics domain, or it could be in any other domains. It doesn't it is not applied for only web and mobile analytics domain. It could be for any domain. So these are the steps we'll be following when it comes to pre-processing. So we will see what exactly the exploratory data analysis, and then we will see how we can do the pre-processing. What are the steps we will be having? What kind of anomalies we will be having in our data, that we will discuss. Exploratory data analysis. So what it is, very first investigation that we will be doing whenever the data is arrived. What we will be finding out using the exploratory data analysis, if you have some hidden insights in your data, or whether you have any anomalies in data, you have to find out those anomalies. If you have any hidden insights, in that case, you have to bring out those inferences so that we can use for the making the business decisions. So the basic questions we'll be asking right after doing the EDA or while doing the EDA is there any existing unique or record ID will be having? What kind of data types? What kind of data type that particular data frame is holding? Our fields are populated with numbers, dates. Same. What are the data types we will be having in our data? Whether we have any nominal data, whether you have any ordinal data, or whether you have any categorical data, continuous data. What kind of data that we have in our data frame? We'll look into it first, and we'll try to, if you have any zero variance cases, if the data frame is all the features are same, in that case we'll be calling that zero variance. We'll be discussing in a minute. So these are the things we have to check. How many values exist for the categorical fields? How many fields have been left blank? Means missing data. How many missing data you will be having? How are multiple data sets are related? Whether we have any correlation in between the input variables and with output variables. So these are all the questions that we have to ask right after receiving the data. So what we will be doing right after receiving the data, first thing that we will be doing the investigation on data. Exploratory data analysis refers to critical process of performing initial investigation on data so as to discover the patterns and spotting the anomalies, to test hypothesis and to check the assumptions. Hypothesis means right after receiving the data, you will be assuming some. You will be making some assumptions. To prove those assumptions, we will be looking for that supports your assumptions. If you have any patterns that supports your assumption, in that case, if those patterns are supporting your assumption, you can simply go with null hypothesis. The assumption that you are doing, if those are wrong, in that case, we will be going with alternate hypothesis. So these are the preliminary diagnosis or the investigation that we will be doing whenever we are receiving the data. And then we'll be seeing whether we have any nominal data, which kind of data type we'll be having in our data frame, whether we have any numerical values, if we have any categorical values, if we have any missing values, Those are the questions that we'll be doing at the very first. This is called investigation. And then whatever the data we will be having, if you have a continuous data, continuous data means if whenever your data you are mentioning in the decimal form and it is making sense, in that case we'll be calling it as the data that you are representing in decimal form and it is making sense. Like cages, 6.5 kgs, 6.5 kgs. You are representing in decimal form and it is making sense. Weight and height 7.5 inches. You are mentioning in decimal form and it is making sense. Wherever data you are mentioning in decimal form and it is making sense, in that case we'll be calling it as a continuous. So whenever you have a continuous data, you can simply do the univariate analysis. I mean, in that univariate, we'll be having the bar plot, you will be having histograms, and you have a box plot. When you have bar plot and when you have a histogram, it will simply show you whether the data frame or the feature that you are taking, is it symmetric or not. And to find out the relation between two variables, that could be input to output or in between input to input. To find out the relation, what kind of correlation it is holding, whether it is strong correlation, weak correlation or moderate correlation. To find out that, we will be going for the bivariate analysis. That includes scatter plot, and we will be having pair plot as well. And then we will be going for multivariate analysis. Here we will be checking the relationship of all the features, pair plot, heat map, how the features are correlated, or the label input with output and input between input as well, using multivariate analysis. These are the different graphical analysis that you can do. It is part of the EDA. And then we can do the statistical analysis. The first moment business decision. In that, we will be calculating the mean, median, and mode of those features. These are the first moment business decisions, measure of segment literacy, also you can say. When it comes to second moment business decision, we'll be having measure of dispersion, variation, variance, and standard deviation. What is measure of dispersion? How far is that the values are from the mean? We'll be calculating the mean and how far it is spreaded. To find out the spread of the data, we will be going for the second moment business decision. And then we'll be having third moment business decision to find out whether the data or the feature that we'll be having, is it symmetric or not. If the data is symmetric, in that case, we can apply all the statistics models. If the data is not symmetric, in that case, we will be converting the non-symmetric data into symmetric data, or normal distribution to normal distribution. So if we don't have data is not symmetric, in that case, we'll be calling as skewness. We have two types of skewness. When you have data long tail on the right side, we will be calling it as right skew. When you have a tail data on the left side, in that case, we'll be calling as left skew. Whenever you have a asymmetric data, in that case, we have to convert that asymmetry or non-normal distribution data into normal distribution, so that we can apply all the statistics on that particular data. It is all about what? Why we are applying all this? In order to bring out the inferences. So whenever you the data science is all about what? You will be having the historical data and you are applying the statistics, mathematical statistics, and transforming the data, and we are bringing out the inferences from that particular data. And then we'll be having the fourth moment business decision to calculate the peakiness and tailness of the data. That we'll be calling as kurtosis, to find out the peakiness and the tailness of the data. So these are the exploratory data analysis that you can do. Using this, you can find out whether the data that you will be having is symmetric or not, and what is the mean of that value, how the data is spreaded. All those things you can find out using the exploratory data analysis. Yeah. When it comes to pre-processing, whenever you have some anomalies in your data, to remove those anomalies, we'll be having pre-processing techniques. It is also called as scrubbing. It is also called as wrangling. We'll be having different names when it comes to pre-processing. The main aim is to eliminate the anomalies that is present in your data. So what type of anomalies can be present in our data? Like we have discussed in the very first, that it could be missing values, it could be same data, it could be null values, there could be outliers. These are the anomalies can be possible. Possible anomalies can be present in our data. So how can we avoid those, or how can we clean those? We'll see now. Pre-processing techniques. First one is typecasting. Whenever you have a data in Python, what happens? It will automatically take which data that particular feature is belong to. Whether you have integer, it will take it as an integer. You don't need to mention that this feature is, or this data type is an integer, it will automatically take it. Whenever it is taking automatically, so based on data set only it will take. But if you want to convert that integer data from float as a float data, you want to use that integer data as a float, in that case, you can simply convert one data type to another data type. Data type to another data type. That is called typecasting. Converting one data type from the converting one data type to another data type, that is called as a typecasting. It could be integer to float or from float to integer. Converting from one data type to another data type, it is called as a typecasting. Duplicates. Let's say you have x1, x2. This is the data frame you will be having. All are inputs. X1, x2, x3, and x4 are all are inputs. If all these inputs having the same information, let's say these are the entries you will be having. If first entry and the fifth entry are exactly same, let's say 5, 4, 3, 1 and 5, 4, C1, and these are some XY, something like that. If these both entries are exactly similar, you are taking the same information in two columns. In that case, it will be duplicate. It will be duplicate. In that, what we'll be doing, we'll simply dropping those duplicates. We are simply dropping those duplicates. So we don't have any imputation techniques when it comes to duplicates. You are taking the same data two times. In that case, it is not. So it is giving the same information, right? So why we need to take the same data two times? So we'll simply drop those. And then we will be having the outliers. And then we'll be having the outliers using the box plot. Box plot means it will look like something like this. Minimum value and the maximum value, and you'll be having quarter 1, quarter 2, and quarter 3. So we'll be forming the upper cutoff and the lower cutoff value based on box plot. The values that are beyond the upper cutoff value and the values that are beyond the lower cutoff value. The cutoff we can form anything like 5% or 2.5% or even 5%. So whenever you are using the upper cutoff value 5%, in that case lower cutoff value is also 5%. So overall 90% data that you are taking, and the rest 5% upper cutoff and the lower cutoff value you are simply removing. So those are, you will be converting into the outliers. Or if you have outliers, you can simply take those as an outlier. You will be forming two upper cutoff and lower cutoff. Whatever the values are beyond that upper cutoff value, we will be considering as outliers. Whatever the values that are beyond the lower cutoff value, will be calling it as outliers. So we have two methods to remove two outliers. That is one, trimming, and next we'll be having mensuration. When it comes to trimming, whatever the values that are beyond the upper cutoff value, that are beyond the lower cutoff value, simply we are removing this. Simply we are deleting those data. Whatever the values that we have beyond the upper cutoff value and lower cutoff value, we are simply removing when it comes to trimming. When it comes to mensuration, whatever the values that we will be having beyond the upper cutoff value and beyond the lower cutoff value, we will simply replacing with upper cutoff and the lower cutoff. Whatever the values that are beyond the upper limit value, we will be replacing with the upper cutoff value. The values are beyond the lower cutoff value, will be simply replacing with the lower cutoff value. Here in mensuration, we are not removing any data or deleting any data, but when it comes to trimming, we are removing the data. That is why trimming is not recommended, since you are deleting the data. Instead of that, we can go with mensuration. These are the two: outlier detection and outlier treatment. We will be using the box plot to detect the outlier, and we are using the upper cutoff and lower cutoff value to replace the outliers with upper cutoff value and lower cutoff value in the case of mensuration. Then we will be having zero variance cases. Whenever you have data or feature, in that feature all the values are same. All the values are same. In that case, let's say you have age column. In that all the features, all the values are 30 only or 32. Anything. All the values are 32 in that case. What could be the mean value? Mean will be 32. And whenever you are finding the dispersion, so you won't be having any dispersion or you won't be having any variance. Variance is means what? How far the other data points from the mean. When you have mean values, all are present on that mean only. Since 32 is the mean, so there are no values that are present in our data set that are far from the mean value. So in that case, it will simply consider it as a zero variance case. Whenever you have zero variance case, you will simply ignoring those columns. Near to zero variance, if you have 1000 data points or 1000 entries, among that 990 entries are all same majority class, and you have just 10 entries different entries will be having. In that case, we'll be calling it as near to zero variance, near zero variance. What does that mean? We'll be having mean, if it considering the age, in that case 32, and just 990 values are on same line. That is the mean. But we have just 10 values that are outside the, or we'll be having some variation, but we won't be considering that variation at all, since it is very small portion of data point we'll be having as a variance. In that case, we'll simply ignoring that feature. These are called near to zero variance and zero variance. When it comes to discretization, whenever you have a continuous data, and you want to convert that continuous data into discrete or binning, in that case, we will be using the discretization. Let's say I have a salary data. Salary, it will be random, right? It will be continuous. 12,500.50, 25,500, 30,500.25, something like that, if I have a data frame. And I want to convert that continuous data into discrete. How can I convert that? Whatever the salaries that I will be having, I am using binning, or using the minimum or mean to segregate those values into low salary and high salary. Whatever the salaries will be having, using the salary column, I'm simply creating two features or two classes. One is low salary and one is high salary, based on mean, or if you have a specific requirement, in that case you can simply mention whenever the salaries are over 45,000, if you have specific requirements, is considered as a high salary. If it is less than that, in that case we will be considering it a low salary. Like that, I can convert the continuous variable into low salary and high salary. That is the discretization. Or you are converting the continuous data into discrete data, or binning. Different, not just two categories. You can convert into different low, medium, and high. You can convert into any number of categories. Missing values. So if you have collected the age, in that case, it could be, there might be people that intentionally they might not be shared with you. In that case, so all this missing value will be having different missing values, missing completely at random, missing at random, missing not at random. Like that, we will be having different missing values we will be having to avoid those missing values. So if you have 1000 data, in that we have about 200 data is missing. In that case, we won't be deleting the whole missing data, right? So in that case, what we'll be doing? We'll be doing for imputation. Imputation technique. Wherever you have a missing values, we are simply replacing with different imputation techniques. Like we have a mean imputation, we have median imputation, We have mode imputation as well. We have other imputations as well, like KNN, regression. Like that, we have different imputation techniques. Based on your requirement, you can go with any imputation technique. But it is recommended wherever you have outliers in your data. When you have outlier data, instead of going with mean imputation, go with median imputation. Go with median imputation. Why? Whenever you have outlier data, mean can be affected. How it is affected? When you have a mean and you have one outlier data, let's say you have 20, 25, these are the different sales you will be having, 20,000, 25,000, 30,000. Normally your average is about 25,000. Suddenly there is an outlier about 1 lakh sales. In that case, if you consider this into calculating the average of the sales, in that case it will definitely affect your data. To avoid that, we can simply go with the median imputation. Median won't be affected with outliers. So mode we will be using when you have a categorical data. Mode we will be using when you have a categorical data. Mean and median will be using for the continuous data. Continuous data. And then we'll be having dummy variable creation. Whenever you have a categorical data and you want to convert those categorical into numerical. Categorical data and you want to convert those into numerical. In that case, we'll be using the dummy variables. Using dummy variables. In dummy variables, we'll be having one-hot encoding. Different we'll be having one-hot encoding. And then we'll be having dummy variable creation, get dummies. And then we'll be having label encoding. And then we'll be having ordinal encoding. There are so many encoding techniques we'll be having. But mainly we'll be using one-hot encoding, dummy variable creation, and label encoding. So whatever the categorical values you will be having, you will be simply using the encoding techniques we are converting into categorical to numerical. And then we'll be having transformation techniques. Whenever you have a data frame, if it is not in a bell-shaped curve, let's assume it is in a bell-shaped curve. Whenever you are applying the machine learning model, you are by default assuming that. By default, you are assuming that the data that you have given, assuming that data is given is not symmetrical or normal, you can say. It will be having normal distribution. By default, you will be assuming that it is a normal distribution. But in real time, you won't be getting cases that are normal. It is very rare. In that case, what you have to do? We have to convert those non-normal data. You have to convert those non-normal data to normal. Converting the non-normal data to normal data, will be calling it as transformation. We'll be calling it as transformation, converting from non-normal data to normal data. So that we can apply all the statistics techniques on that particular data. And then we'll be having standardization. So whenever you have a data, let's say x1, x2, x3, these are the data frame we'll be having. In that data frame, if you have a data frame, x1 is about 1.5, x2 is 30, it is 10,000, and it is 105. The inputs are the range is very high, the difference or the variance in between each input is very high. Here we'll be having just 1.5, and here you have just 30, and you have 10,000. The variance is too much. Whenever you have a too much variance, in that case, there could be a possibility of biased output or biased prediction. There could be a possibility of biased prediction. In that case, what we'll be doing? To avoid that, we will be converting the data frame into standardization or normalization. We'll be doing standardization or normalization. Both are used for the same reason. We'll be converting the different variant data into single. So what happens in normalization, we'll simply converting the whole data frame, whatever the data frame will be having in between 0 to 1. In between 0 to 1. But when it comes to standardization, mean is equal to 0, whatever the data that you have created, mean is equal to 0, and standard deviation is equal to 1. For the whole data, the mean will be 0 and the standard deviation is equal to 1. And those data are spread in between -infinity to +infinity. The range, normally, theoretically, the range could be -infinity to +infinity, but in practical, it will be having in between -3.4, 1.4, -3.14 to 3.1. This is the range of values that you will be getting after doing the standardization. And then we have string manipulation, slicing. You want to accept. See, whenever we are talking about the string, in that case, it is unstructured data. String. So if you want to do the slicing, or you want to access the specific information from the sequence, in that case, we will be using the string manipulations that we will be learning when you have a text NLP or unstructured data, whenever you are talking about the unstructured data. These are the pre-processing techniques when it comes to structured data. Structured data and then string manipulation. The same when it comes to unstructured data. When you have unstructured data, in that case, we will be having different types, so that we can apply the algorithms of NLPs. So for that, we are having text pre-processing. In that, we'll be having tokenization, normalization, noise removal, and we'll be having other techniques as well. So that we can use the NLP algorithms on that particular data. Whenever you are collecting the data from the source, or you are doing the web scraping. Whenever you are doing the web scraping, or you are collecting the data, in that case, what kind of anomalies you might be getting if you are doing the web scraping? HTML tags will be having. And when it comes to Python, it is a case sensitive. It is case sensitive. Let's say tab and tab. It will consider both as different words. So it is always case sensitive. So whenever you are collecting the data, it might be having the capital, uppercase. So it will be considering as a different cases. And you might be having different numbers. So in order to clean that, we have to avoid all those things. In order to apply the algorithm, we have to clean all this data. Yeah. Tokenization. What is tokenization here? Whenever you have received the data, we are simply converting into different words. Let's say this is one data frame you will be having. You are simply, wherever there is a space, you are splitting into different data. Different words or tokens. You are simply converting into different tokens, and then we will be applying whatever the algorithm that you want. You want to clean it, or you want to apply any SOP tags, POS tags, all those things that will be applied. And if you want to remove, any stop words, if you have that is not providing any information, if you are doing the sentiment analysis, joining words like add, and so these joining words are not necessary for the sentiment analysis. In that case, you might be removing those data. So these are the different pre-processing that you will be doing when it comes to unstructured data. Yeah, what are the anomalies we'll be having? Tags, HTML tags. There is a possibility of having the HTML tags since we are doing the web scraping from the different websites. White spaces, you might be having the extra spaces, and you might be having different characters, like hash and something like these characters. You might be having special characters, lowercase, convert numbers from words numeric. So what we'll be doing here, whenever you have data something like that, you have to remove those HTML tags. You have to remove the extra spaces, whatever the values you will be having. You have to convert into the ASCII standards. And if you have a special characters, you have to remove those special characters. If you have the uppercase letter, since the Python is case sensitive, you have to convert all those letters into the lowercase. Convert all the letters into lowercase, and then we will be converting all the letters into numerical format. Converting into numeric formats. If you have numbers in your data, in that case, we will be removing that numbers as well. If you are going for the sentiment analysis, the stop words doesn't provide any sentiment for you. In that case, we will be removing those stop words as well. And the lemmatization. Whenever you have data, let's say converting the given word into root word. That is called as a stemming. But we have a problem with the stemming. Whenever you are doing the stemming, it doesn't care whether that particular word is present in your dictionary or not. So it will simply remove those extensions. Let's say it is a tackle. It will simply tackling. It will simply remove ing, but doesn't care whether this tackle word, TACKL, is it present in your dictionary or not. It doesn't care when it comes to stemming. To avoid that, we will be going with lemmatization. We will be going with lemmatization. What does lemmatization do? It will do the stemming work as well as it will look into the data frame. It look into the data and it will look into the dictionary whether that particular data or the word, whatever the converted word or root word will be having, whether we have in dictionary or not. If we have in dictionary, in that case, it will keep as it is. If we don't have in the dictionary, in that case, it will replace the word which is near to that word. It will simply replace with a word that is near to the word that is present in the dictionary. So these are the different pre-processing techniques we'll be having. Pre-processing. One for both structured data and the unstructured data. It is for both structured data and unstructured data. Once the pre-processing is completed, we will be all the pre-processed data set we will be feeding to the machine learning model. Machine learning models, and we are training that particular machine learning model. If you are going with structured data, in that case, we'll be having two. One is supervised and unsupervised. And in supervised, if you have labels, in that case, we'll be converting main data frame, whatever the pre-processing that we have done, the data set into training and testing. And then we'll be training the model using the training. And then we are testing the that particular model using the test data. And then we are building we are training the machine learning model, and then we are evaluating, and once that is done, we will be deploying. So like that, we will be doing the pre-processing. It is for both structured data. We have discussed both structured data pre-processing as well as unstructured data pre-processing. Yeah. So yeah, guys, this is how you will be doing the pre-processing for different data set. Once the pre-processing is done, then you will be applying the same data to the machine learning algorithm, since it is a clean data. Yeah, I hope you guys learned something from this video, and if you would like to transform your career into data science, in that case, you can simply contact 360DigiTMG, or you can simply follow. If you want to looking forward to kind of this kind of videos, you can subscribe to 360DigiTMG channel. And if you want to kickstart your data science career, we have started our Python session with the name of Tame Python Sessions. Tame Python session. These are free. You can simply go to 360DG channel in YouTube and you can watch. And yeah, I hope you guys learned something. In the next video, we'll be coming up with unsupervised learning. Unsupervised learning. I'll be taking one algorithm in unsupervised learning, that is K-means. We'll be taking one use case scenario when it comes to web and mobile analytics domain. We'll be taking one use case scenario using the in this domain, and then we'll be building the model. Yeah, I hope you guys learned something, and we'll see you in the next class, and have a nice day.